Welcome to Math 40. In this lecture video, we're going to be considering lecture notes week 12 and 13, which were recently posted onto Canvas. I do encourage you to have your formulas and identity sheet handy, as these set of lecture notes will still address problems that use these formulas. So it's a good idea to have this on the side, that way you can refer back and forth. Okay. So the first type of problem that we're going to be considering is finding function values given information on angle theta. And the identities that you want to consider are the fundamental, cofunction, sum and difference, double angle, and half angle formulas. So it's quite a bit. I'm going to give you some tips along the way of how to narrow down that very wide array of selection. So example number 1 reads, find one value of theta or x that satisfies each of the following. In part A, we have cotangent of theta is equal to tangent of 25 degrees. Now, if you look at the formulas, you want to take into consideration formulas that have only one term and that relate cotangent to tan. So maybe you might start looking at the top left-hand corner because this reads tangent and cotangent identities, and we do see tan and cotangent. But these identities actually relate to sine and cosine rather than cotangent and tangent. So we can consider other formulas such as reciprocal identities. This third one has a relationship between tangent and cotangent. But again, we don't, in our case, have a reciprocal, so that's probably going to be ruled out. And if we continue looking, go down to the bottom right-hand corner, and you'll find the cofunction formulas. The third one on the first column has a tangent of pi over 2 minus theta is equal to cotangent of theta. So here we see a relationship between tangent and cotangent, but I guess more importantly is the fact that we see cotangent of theta by itself on one side of the equation, the same as what we have on our problem. So that's the one that I'm going to try to use. Let me go ahead and write it over on page 1 of our notes. So the formula reads cotangent theta is equal to tangent of pi over 2, but since we're working with degrees, we're just going to convert that pi over 2 into 90 degrees. So 90 degrees minus theta. And we are trying to find what is the value of theta by using this formula. So if we compare against what we have, we see the left-hand sides agree. We have cotangent and cotangent. The right-hand sides agree in terms of the trig function, but the angle, we have 25 degrees instead of 90 degrees minus theta. So in order for these two equations to be exactly the same, we have to set the 25 degrees equal to the 90 minus theta. So this means that 25 degrees must equal 90 degrees minus theta if we want the expression to be true. And when we do that, we see then that there is a way to solve for theta. We can isolate by adding first theta to both sides, in which case we're going to get theta plus 25 degrees is equal to 90 degrees. And then we can subtract 25 from both sides, in which case we're going to get theta is equal to 65 degrees. Okay, so what we're saying then, if you look back at the original expression, is that cotangent of 65 degrees will give us the same thing as tangent of 25 degrees. And so the nice thing about these problems is that we can always verify our work by taking this value and replacing into the original expression, then making sure that the equation is true, and that we get the same values on either side of the equal sign. So let's see, let's start with tangent of 25. First, I'm going to check that I'm in degree mode, and it seems like I am. So I'm going to go back. Tangent of 25 degrees gives us approximately 0.47. And then if I try cotangent, remember on the calculator, we have to write this as a 1 over tan. So 1 over tangent of 65 degrees, because we are taking cotangent of theta, and theta we're saying is 65. So 1 over tangent of 65 degrees gives us exactly the same number as tangent of 25. So now we can be assured that the answer that we got here is correct. Okay, so that is for part A. Part B has a similar problem, but in this case we have sine. So now we're going to look for a formula that relates sine theta to cosine of some angle. And if we focus again on the cofunction formulas, you'll see that there are, there are two formulas, one that deals with cosine, one that deals with sine. The one that we want to focus our efforts on is the one with sine theta, because that's what we have in our problem. So that would be the one in the second column. Okay, the formula reads sine theta is equal to cosine of pi over 2 minus theta, but we of course can always change this to 90 degrees. So let's write that down. So we have sine of theta equals cosine of 90 degrees minus theta. Okay, so again we compare against the expression that we have. We have sine theta, so that's the left-hand side's degree, is equal to cosine of negative 30 was given to us, and we're trying to match it to the formula. So we have to match the negative 30 to the 90 degrees minus theta. Okay, so that means we have negative 30 degrees is equal to 90 degrees minus theta. Okay, and again, we just solve for theta at this point. That means adding the theta to both sides, which is going to give us theta minus 30 degrees is equal to 90. And finally, add 30 to both sides of the equation to give us 120 degrees. And let's verify our answer. So if I replace the 120 back into the equation, we're saying that sine of 120 is the same as cosine of negative 30. And so first, we'll look at sine of 120, and that gives us about 0.86. And now we'll look at cosine of negative 30, and that gives us, again, the same number. So that means our answer is correct. Okay, and one more, part C. Part C, we have cosecant of 3 pi over 4 is equal to secant of x. So we're going to compare against the cofunction formulas. Here we have one that relates cosecant and secant, and then we also have one that relates secant, cosecant of theta. So the one that we want to work with is this first one, or I guess the second one in the first column, because that's the one that has secant of an angle by itself. In our case, it's x. In the formula, it's theta. But we can always change that to suit our needs. So we're just going to change it to x. Okay, so we'll write it down first. Alright, so the formula reads cosecant of pi over 2 minus x is equal to secant of x. And this time we're leaving it in radians because the cosecant is given to us as radians. Alright, so now we compare. We have the left-hand side will be equal when the 3 pi over 4 is the same as the pi over 2 minus x. And then the right-hand side, secant x already agrees, so we don't really need to do anything there. Okay, so what does that mean? That means that we're going to have a pi over 2 minus x be equal to a 3 pi over 4. And now we're going to solve for x. So that means add an x to both sides. And that'll give us a pi over 2 equals 3 pi over 4 plus x. And then subtract a 3 pi over 4 from both sides. So we're going to end up with x is equal to pi over 2 minus 3 pi over 4. Now in order to carry out the subtraction, we're going to multiply top and bottom of the first fraction by 2. So we'll get a 2 pi minus a 3 pi, and that'll give us a negative pi over a common denominator of 4. So we get a negative pi over 4. And again, we can check it by punching into the calculator. In this case, since we're dealing with secant and cosecant, we're going to have to use the reciprocal function, so that would be 1 over sine and 1 over cosine. So I'm going to go ahead and start with cosecant, which is going to be 1 over sine. And before I go any further, let's go back and change from degree to radian mode now. Okay, so we have 1 over sine of 3 pi over 4, and it gives us a 1.41. Now for secant, we're going to need a 1 over cosine, and x we solved for and got a negative pi over 4. So we get exactly the same numbers, and now we're sure that the answer that we found is correct. Okay, example 2 is a slightly different problem. In this case, they gave us information about tangent of theta. They tell us if tangent of theta is negative 5 over 3 and theta is in quadrant 2, find each of the function values. And we have 3 to find, which is sine theta, secant theta, and cotangent of negative theta. Okay. So first, let's try to picture the given. They tell us that the angle terminates in quadrant 2, so I'm going to go ahead and draw that. Okay, and they also tell us that tangent of theta is negative 5 over 3. So this is theta, and they give us information. Tangent theta is negative 5 over 3. Now, when we find the trigonometric functions of the angle theta, we consider the reference angle, which lies between terminal side and the part of the x-axis that makes an acute angle with the terminal side. So in this case, it would be this angle here. Right, that's our reference angle. And based on this right triangle that we make with the reference angle, tangent of theta would be opposite over adjacent. Okay, so this is opposite, this one's adjacent, and they tell us that the fraction by itself is a 5 over 3, and we do have that negative that we would need to consider in terms of direction. So the opposite side is definitely going to be 5, because it has to be in the numerator. And then over adjacent, we're going to have a 3. And then as far as where the negative goes to the 5 or the 3, well, the 5 is going in the positive y direction, so the 5 wouldn't receive the negative. The 3, however, is going in the negative x direction. That means that 3 is the number, or negative 3 would be the label that we would want to place on the adjacent side. Okay, so based on this now, we are able to find any other trig function for theta that we need. For part A, they're asking us for sine of theta. So sine of theta would be opposite over hypotenuse. Right, so we're going to first apply Pythagorean theorem to help us find the hypotenuse, and that's going to be a squared plus b squared equals c squared, where c squared is the hypotenuse. So we'll have a negative 3 squared plus 5 squared is equal to c squared. And then c squared is going to be a 9 plus a 25. That means that c squared is going to be a 34, which means that c will be the square root of 34. And remember, we're taking the positive here because hypotenuse is a distance, and that one has to always be positive. Okay, so now based on this, which is square root of 34, we can find sine of angle theta, which we said is opposite over hypotenuse, and that is going to be 5 over square root of 34. Now we normally don't like to have radicals in the denominator, so we have to rationalize. That means multiply top and bottom by a square root of 34. And so we get 5 square root of 34 divided by 34. And that would be our final answer for part A. For part B, they're asking us for secant theta. Now secant theta is 1 over cosine, and cosine is adjacent over hypotenuse. So in terms of adjacent and hypotenuse, secant is hypotenuse over adjacent. Okay, so the hypotenuse we already found to be square root of 34, and the adjacent was a negative 3. Okay, so in the end we just have a negative square root of 34 over 3. And finally, part C, where we have cotangent of negative theta. Notice the diagram that we drew is not for negative theta, it's for positive theta. So we need to rewrite cotangent so that it no longer has that negative in the argument. And if you recall, when we were talking about the graphs of the functions, we said that tangent and cotangent are both odd functions, which means that if there is a negative in the argument, that negative can always come out of the function. You don't have to memorize that. You can also just refer to the formulas and identity sheet. And if you look under the even and odd formulas, cotangent of negative theta is equal to negative cotangent of just theta. Okay, so that's what we're going to do here. We're going to first apply cotangent of negative theta is equal to negative cotangent of theta. And I'll just write a little note here. This is because cotangent is an odd function. Okay, so now that we have that, we can focus on what is cotangent. Well, cotangent is just going to be the reciprocal of tan, and tangent was given. It was given as a negative 5 over 3. That means cotangent has to be a negative 3 over 5. Okay, so we're going to have negative of negative 3 over 5. And then negative times negative will give us a positive. So in the end, our final answer will be 3 over 5. For example number 3, we have, suppose that sine of s is 3 over 5, cosine of t is negative 12 over 13, and both s and t are in quadrant 2. Find cosine of s plus t. Okay, now this one is similar to example 2, except that we have to find cosine of s plus t rather than just maybe cosine of s. Now cosine of s plus t, we've worked with sum and difference formulas before, and it looks very similar to the left-hand side of the sum formula for cosine. In fact, the only difference between the cosine of s plus t and cosine of alpha plus beta is the variables, right? So we're going to apply the sum formula for cosine to help us find what is cosine of s plus t. And so I'm going to start by writing down the formula on our notes. Cosine of s plus t is equal to what's going to be cosine of the first variable, so that would be cosine of s in our case, times cosine of the second variable, that would be cosine of t in our case. Now, because we chose the top symbol, which was a plus, on the left-hand side, we have to choose the top symbol on the right-hand side as well, which is a minus. So we have minus. And then sine of a times sine of b, so that's sine of the first variable, which is s, times sine of the second variable, which is t. Okay, now notice a couple things. We need to find, we need to plug into the formula what sine of s is. And sine of s was given to us, right? They gave us that value. So that's already given. We know that. We also have to use cosine of t, and luckily that was also given. So the information that we're missing then, in order to compute cosine of s plus t, is going to be cosine of s and sine of t. So I'm going to color code those. So we're missing cosine of s and sine of t. Alright, so how can we find what is cosine of s and sine of t? Well, let's look at the other given information. They tell us that both s and t are in quadrant number 2. So it might be a good idea to draw the diagram. I'm going to draw the s angle separate from the t angle. Right, so here on the left-hand side, I'll start drawing S. So vertex at the origin, initial side on the positive x-axis, and then we have the terminal side somewhere in quadrant number 2, and we're going to call this S. Okay. Now the given information is that sine of S is a 3 over 5. So sine, if you recall, is opposite over hypotenuse. So that means that the opposite side has to be 3, because that's what's given in the numerator. And hypotenuse has to be 5. Okay. Now the missing side then would be the adjacent side. But we can use Pythagorean theorem to help us figure out what that is. Okay, so we'll have a squared plus b squared equals c squared again. But now a is unknown, b is 3, and c is 5. So we'll have a squared plus 9 is equal to 25. That means that a squared is going to be 16. And that means that a will have to be either a positive or negative 4. Now in this case, because the adjacent side lies on the negative x-axis, that means that we need to have a negative 4. Okay, so the adjacent side will be negative 4. Right, now what information can we retrieve from this? Because we're dealing with s, we can find cosine of s. Right, cosine will be the adjacent over hypotenuse. So let's write that down. Cosine of angle S will be the adjacent over hypotenuse, which is a negative 4 over 5. And now we have one of the two pieces of missing information. What about for angle T now? Well, again, we'll draw the vertex at the origin, initial side on the positive x-axis, and terminal side in quadrant 2, because they tell us that's where it ends. And I'm not, I don't know exactly where the terminal side lies or how large this angle is. I'm just drawing it a little differently from S so that we can distinguish the two diagrams. Okay, but if we draw it in that way, that means that for cosine of t, that would be the adjacent over hypotenuse. So the adjacent side would have to be 12. Hypotenuse would have to be 13. And notice one of the two has to be negative because we are given negative 12 over 13. The hypotenuse can't be negative, so the adjacent side must be the 1. And that agrees with the fact that the adjacent side, again, is on the negative x-axis. Okay. So now we're going to apply Pythagorean theorem to help us find the missing side. And now we have negative 12 squared plus b squared is equal to 13 squared. That'll be a 144 plus b squared is equal to 169. That means that b squared will be 169 minus 144, which will give you a 25. And that means that b could either be positive 5 or negative 5. Now b is representing this opposite side, and the opposite side goes up in the positive y direction. So that means that we're going to pick the positive 5. Alright, so what does that mean now? That means that we can find what is sine of t. Sine of t is opposite over hypotenuse. And now we're focusing on this diagram. Opposite is going to be 5. Hypotenuse will be 13. So now we have sine of t. Alright, so that is all the information that we need in order to compute cosine of s plus t, which is the original goal. So let's write that down here. Cosine of s plus t, we said, would be cosine of s times cosine of t minus sine of s times sine of t. And cosine of s, we found, that was negative 4 over 5. Cosine of t was given to us, negative 12 over 13. Sine of s was also given to us. It was 3 over 5. And sine of t we found is 5 over 13. Okay, so now it's just a matter of simplifying the computation. So negative times negative will be positive. 4 times a 12 will give us a 48. 5 times a 13, that'll give us a 65. Minus 3 times a 5 will be a 15. 5 times a 13, again, that's a 65. Now 48 minus a 15, that's going to give us a 33 over 65. And that would be our final answer. Alright, example 4 is similar to example 3. It reads, suppose that A and B are angles in standard position such that sine of A is 4 over 5 and A is found between pi over 2 and pi, and cosine of B is negative 5 over 13, where B is between pi and 3 pi over 2. Find each of the following. And there's a couple of typos on this part, so I've gone ahead and corrected it, and you can correct it on your set of lecture notes as well. So part A will be to find sine of A plus B, but then part B should be tangent of A plus B, and part C should be the quadrant of A and B. So it's just the order that's switched around. Alright, so again, they're asking us to find a trig function of a sum of two angles. So in the case of part A, for instance, we can look at what formula has sine of A plus B. Again, that's the sum formula for sine, which says sum of A plus B, or sine of A plus B is sine of A cosine B. So let me write that down. This is equal to sine of A cosine B. And if we chose the top symbol on the left-hand side, we have to choose the top symbol on the right-hand side. So that'll be plus cosine of A times sine of B. So plus cosine of A times sine of B. Okay, so that's for part A. We need to find sine of A plus B. Now, notice they gave us sine of A. Right, sine of A is here. So this we have. They also gave us cosine of B. Okay, so that we also have. That means that in order to compute sine of a plus b, we're going to need to know what is cosine of a, as well as what is sine of b. So just like before, we're going to be drawing the diagrams, starting with angle A. Now, angle A, they tell us, lies between pi over 2 and pi. Pi over 2 is like 90 degrees, and pi is 180. So if it lives between 90 degrees and 180, that means it lives in quadrant 2. Okay, so I'll draw my diagram focusing on quadrant 2. Alright, so here we go. Vertex at the origin, initial side on positive x-axis, and then terminal side is somewhere in the second quadrant. Okay, and then we know that the opposite side has to be 4 because sine of A is 4 over 5. So opposite side is 4, and then the hypotenuse is going to be 5. Right, so what are we missing in terms of angle A? We're missing cosine of A, which means we're going to need the adjacent side. Okay. If you do a little Pythagorean theorem, you'll find that the adjacent side will be 3, but we're going to add that negative because we're going in the negative x direction. And so that tells us that cosine of A will be a negative 3 over 5. Okay. Now we'll take a look at angle B and draw a diagram for that angle. Now B is between pi and 3 pi over 2. If we think about it in degrees again, pi is 180 degrees, 3 pi over 2 is 270. So an angle that lives between 180 and 270, that would be quadrant number 3. So we're going to draw our diagram, but focusing on quadrant 3. Initial side on the positive x-axis, vertex at the origin, and now we're terminating somewhere in quadrant 3. Now what's given about this angle, which is B, is that cosine is negative 5 over 13. So cosine is adjacent over hypotenuse. That means the adjacent side has to be negative 5 because we're going in the negative x direction, and hypotenuse has to be 13. That means we're missing the opposite side. Again, if you apply a Pythagorean theorem and you solve for it, you should get that this is negative 12. And now we're ready to find sine of angle B. According to this diagram, sine of angle B is going to be opposite over hypotenuse, so that'll be a negative 12 over 13. Okay, and so now we're ready to find sine of A plus B. Let's write this down. We have sine of A plus B will be equal to sine of A, and sine of A was given as a 4 over 5, times cosine of B. Cosine of B was given as a negative 5 over 13, plus a cosine of A. Cosine of A, we found it to be negative 3 over 5, times the sine of B. Sine of B we found as negative 12 over 13. Okay, so let's simplify this. Positive times negative will give us a negative answer. 4 times 5 will give us 20. 5 times 13 will give us a 65. Negative times negative will give us a positive, so we're going to keep the plus. 3 times a 12 will give us a 36. 5 times a 13 will give us a 65. Okay, so in the end, we have a negative 20 plus a 36. That'll be a positive 16 over 65 for sine. Okay, let's move on to part B, which is tangent of a plus b. Again, if we look at our formula sheet, we also have a sum formula for tan. It says the following. It says tangent of a plus b has to equal tangent of a plus tangent of b divided by a 1 minus tangent of a times tangent of b. So let's write the formula down first. Tangent of a plus b is equal to tangent of a plus tangent of b, all divided by a 1 minus tangent of a times tangent of b. Alright, now none of these were given, right? Tan A we don't know, tan B we don't know, but we've already drawn the diagrams, and we can read what tangent of A and tangent of B are going to be from the diagrams. Okay, so let's do that. I'm going to color code this blue. And this red. Okay. So tangent of A, according to this first diagram, is going to be opposite over adjacent. So that'll be a negative 4 over 3. Now tangent of B, according to the second diagram, is going to be opposite over adjacent. So that's a negative 12 over negative 5. Our final answer will be 12 over 5. Okay. So now we can take those results and plug them into the formula to simplify for tangent of A plus B. Let's see what we get. We're going to get a tangent of A, which is negative 4/3, plus a tangent of B, which is 12 over 5, divided by a 1 minus tangent of A, that's a negative 4/3, times a tangent of B, that's a 12 over 5. Okay, so whenever you have a complex fraction like this, you have the option of first finding what is the least common denominator of all of the fractions and multiplying through, or just going ahead and simplifying by adding first everything in the numerator and anything in the denominator and then simplifying. I like to look for the least common denominator of all, that way I deal only with integers. So what I'm going to do first is I'm going to simplify this product to get a negative 4/3 plus 12 over 5 all over 1. Negative times negative will give us a positive. 4 times 12 is going to give us a 48. 3 times a 5 will give us a 15. So what we're looking for then is the least common denominator of 3, 5, and 15, which is going to be 15. So I'm going to multiply top and bottom by 15. And in the numerator, that means we're actually distributing to two terms, same as in the denominator, right? So 15 times a 4 over 3, that's like taking 15, dividing by 3, which will give you a 5, and then multiplying by a negative 4. That'll give you a negative 20. Then 12 over 5 times 15, that's taking 15, dividing by 5, which will give you a 3, and then multiplying the result by 12. So 3 times 12 is going to give us a 36. Okay, same thing in the denominator. 1 times 15 is just a 15. 48 over 15 times 15 is just going to give us 48. So in the end, we end up with 16 over, here we're going to have a 63. Okay. So what now? We have part C that's still pending. Part C is the quadrant of A plus B. Okay, so we're trying to find where does A plus B lie? And so to solve this problem, let's think about the two pieces of information that we know about A plus B, the angle A plus B. So one piece of information that we found is that sine of A plus B is equal to 16 over 65, right? So it's positive. The sine of the angle is positive. The second thing that we found out is that tangent of A plus B is 16 over 63, which is also positive. So now if we think about in which quadrant, 1, 2, 3, or 4, do we have both sine and tangent being positive? Well, let's see. If we do a quick diagram, we remember that acronym, all students take calculus. Here, all of the functions are positive. Here, sine is positive. Here, tangent is positive. And here, cosine is positive. So the place where, or the quadrant in which both sine and tangent will be positive will be in quadrant number 1. So that means that A plus B must be in quadrant number 1. Alright, let's take a look at example 5. Example 5 reads, given cosine theta is 3 over 5 and sine of theta is less than 0, meaning it's negative, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Okay, so again, it might be a good idea to draw a diagram for the given information, and then we'll focus on what is sine of 2 theta, cosine 2 theta, and tangent of 2 theta. Okay, so they tell us that cosine of theta is 3 over 5, and sine of theta is negative. Even though they don't tell us explicitly where the angle lies, we do know two things. We know that cosine is positive, because it gave us a 3 over 5. And then the second thing we know is that sine of theta is negative. And that's by the second given. So we think about which quadrant has a positive cosine but a negative sine value. Well, cosine is positive in quadrants 1 and quadrant 4. Sine is negative in quadrant 3 and quadrant 4. So the place where both of those overlap would be quadrant 4. Okay, so again, I'll just draw a little diagram here if you're confused about what I just mentioned. So cosine is positive here and here. And then sine is negative here and here. So the place where they both overlap, both of these conditions, is in quadrant number 4. So theta will be in quadrant number 4. By the way, I've been drawing this symbol, and I don't think I've reminded you what it means. It means in. Okay, that simply means in. Theta is in quadrant 4. Okay, so now that we know that, we can draw the diagram. we're going to focus on quadrant number 4. Okay, so here it is, initial side on the positive x-axis, and then the angle rotates and terminates in quadrant number 4. That's theta. Alright, so what do we do from there? Well, now let's look at what is the goal. The goal is to find sine of 2 theta, cosine 2 theta, and tangent 2 theta. So I'm going to focus on that part, sine of 2 theta first. If we look at the formulas in identity sheet, there is one section called double angle formulas. And there we see sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So we can use the double angle formula, which tells us sine of 2 theta will be 2 times sine theta times cosine theta. Okay, now cosine theta was given to us. So the only thing that we're missing in order to compute the sine of 2 theta would be the sine theta. But we are given the cosine theta is equal to 3 over 5, and we have this diagram. So we can just label the known sides to find the unknown and then find sine. So labeling the known sides, cosine theta means that we have adjacent over hypotenuse. So the adjacent side would be 3, the hypotenuse would be 5. And a little bit of Pythagorean theorem will let us know that this opposite side is going to be negative 4. What does that mean? Well, that means that sine of theta is going to be opposite, which is negative 4, over hypotenuse, which is 5. Okay, so we get a 2 times negative 4 over 5 times cosine of theta, which was given to us as 3 over 5. Yeah, so now we can multiply these together, and we'll have a 2 times a negative times positive will give us negative, 4 times 3 will give us 12, 5 times 5 will give us a 25. And then this is like a 2 over 1, so a 2 times a negative 12 will give us a negative 24 over a 1 times a 25, that is just a 25. So that is sine of 2 theta. Okay. Now let's take a look at cosine of 2 theta. Now cosine of 2 theta is interesting because the formula actually has 3 different versions that you can use. You can either use cosine squared theta minus sine squared theta, 2 times cosine squared theta minus 1, or 1 minus 2 sine squared theta. Now, we should probably pick the one that sticks to only the given information, meaning we should stick to the one that doesn't use any of our own calculations, just to avoid any potential errors from carrying over. So if they gave us cosine theta, there is a formula that has only cosine theta. So we'll use the second version of the formula. So this is a 2 cosine squared theta minus 1. Now, remember that when you see the square attached to the trig function, that actually means that you take cosine of the angle first, and then you square the result. It's just a shorter notation to write it as cosine squared theta. Okay, so from there we're going to have a 2 times cosine, which is a 3 over 5, and then squared, minus 1. Again, what I'm doing here is I'm simply replacing this given cosine value. Right, so what does that simplify to? Well, this is going to simplify to a 9 over 25. So we have 2 times 9 over 25 minus 1. Then a 2 is the same as a 2 over 1. So 2 times a 9 will give us 18. And then a 1 times a 25 will give us a 25. Minus 1. Well, now that I know that I'm going to be subtracting fractions, I want to write that 1 as a 25 over 25. So we have common denominator. Okay, so 18 minus 25, that is going to give us a negative 7 over 25. Alright, and there's one more piece of information that they're asking for, and that is tangent of 2 theta. Alright, so we have two options here. The first option is to use the double angle formula for tangent. So I'm going to do it in this way. But the second option is to maybe use the tangent cotangent identities that tell us that tangent of any angle will be sine of the same angle divided by cosine of the same angle. So in our case, we already have what sine of 2 theta is and what cosine of 2 theta is. So we could just take sine 2 theta divided by cosine 2 theta, and that'll give us tangent 2 theta. But just so that we have practice with the double angle formulas, I'll show you this route. Okay. So the formula reads tan 2 theta equals 2 times tan theta divided by 1 minus tan squared theta. Okay, so we're going to use the diagram to help us find what is tangent. And earlier I forgot to highlight this in green for our sine, but I'll be using the same color to highlight our tangent. Okay. Tangent theta is going to be opposite over adjacent. So that's a negative 4 over 3. Okay, so we're going to take this result and replace it into here. Okay. Now, that would mean a 2 times a negative 4 over 3 divided by a 1 minus negative 4 over 3 squared, because this is a tangent squared theta. So what that means is that we'll have a negative 8 over 3 in the numerator divided by a 1 minus negative 4 squared is a 16, 3 squared is a 9. Okay, so 1 minus 16 over 9. And again, you have two options here. You can either simplify this first and then consider the numerator, or you can multiply top and bottom of the fraction by the LCD of 3 and 9. That would be a 9. So that means that here we have a negative 8 over 3 times 9, which is the same thing as 9 divided by 3, and that's a 3, times a negative 8, so that'll give us a negative 24, divided by, in this case we're going to have to distribute to two terms, so 9 times 1 will give us a 9, minus 16 over 9 times 9 will give us 16. So we get a negative 24 over 9 minus 16, that'll give us a negative 7. So the final answer would be a positive 24 over a positive 7. We're going to consider one last example, example number 6. This one asks us to find the values of the 6 trigonometric functions of theta, given that cosine of 2 theta is 4 over 5, and theta is between 90 degrees and 180 degrees. Okay, so in this case, we're kind of working opposite to the direction that we were in example number 5, meaning we already have what cosine of 2 theta is. We want to now use that information to help us find just sine of theta, cosine of theta, and tangent of theta, and the reciprocals of those three functions. So let's look at the formula for cosine of 2 theta. What does it say? Well, there are three versions. One of them deals with both cosine and sine. But the second and third deal with one trig function at a time. For example, the second one has cosine squared theta minus 1, or 2 times cosine squared theta minus 1. The third one has 1 minus 2 sine squared theta. So we could use these two to help us isolate for cosine and sine respectively. So that's what I'm going to do. I'm going to focus first on the second version and solve for cosine. So we'll have cosine of 2 theta is equal to 2 cosine squared theta minus 1. And before I plug in anything, let's just solve for cosine theta first. Okay, so I'm going to add a 1 to both sides, and that'll give me cosine 2 theta plus 1 is equal to 2 times cosine squared theta. I'm then going to divide by a 2, or the same thing, it gives you the same result if you multiply by a half. So I think that's probably going to look neater. So I'll have a 1/2 times cosine 2 theta plus 1 is equal to, just so that you guys can see what I'm doing here, I'm going to multiply both sides by 1/2. Okay, I'm doing that in the place of dividing by 2, because then these cancel. And so we get, if we distribute the 1/2 here, we'll get a 1/2 cosine of 2 theta plus a half is equal to cosine squared theta. Okay, we're very close now. We have cosine theta will be equal to, I'm simply rewriting, I'm switching the sides here of the equality. Cosine theta will be plus or minus square root 1/2 cosine 2 theta plus 1/2. Okay. Alright, so we're done isolating cosine. Now we can just plug in what is cosine of 2 theta, and we can also determine whether our answer will be positive or negative based on other given information. Okay, so let's first take a look at that second piece of given information, which we haven't considered. They told us that the angle lies between 90 and 180. That would be quadrant number 2. In quadrant number 2, what is cosine? Well, cosine is going to be negative. So let's write that down. So notice, it's given that angle theta is between 90 degrees and 180. So i.e., angle theta is in quadrant 2. So given that theta is in quadrant 2, cosine is going to be negative. So given that theta is in quadrant 2 and cosine theta is negative in quadrant 2, that means cosine theta will be negative square root of 1/2 cosine of 2 theta plus a half. And now we're ready to plug in the given information. So given that cosine 2 theta is 4/5, we'll replace that into here. And we're going to get negative square root of 1/2 times 4/5 plus 1/2. And that's going to be negative square root of a 4/10 plus a 1/2, which is the same as, I'm going to multiply top and bottom here by 5 to get a common denominator. That'll give me a 4 plus a 5, which is a 9/10. And then we're going to try to rationalize this. So we're going to have a negative square root of 9 over square root of 10. That's a negative 3 over radical 10. And then we multiply top and bottom by radical 10 to give us negative 3 radical 10 over 10. and that's cosine. Now from cosine we can find the reciprocal function. The reciprocal function is secant. So for secant theta, I'm going to flip the answer that wasn't rationalized yet. I'm going to flip the -3 over radical 10 to get a negative radical 10 over 3. Okay, so now we go back to the formula because now we're missing sine. And if we look at cosine 2 theta, the third version of it deals with just sine. Okay, so we're going to have as a formula cosine of 2 theta is equal to 1 minus 2 sine squared theta. And again, that means that we're going to be solving for sine of theta. So first we'll subtract the 1. And we'll get cosine of 2 theta minus 1 equals a -2 sine squared theta. Then if we multiply by a -1/2 both sides of the equation, we'll end up with a -1/2 cosine 2 theta plus a 1/2 is equal to sine squared theta. Then if we take the square root, we're going to end up with sine of theta equals plus or minus square root of -1/2 cosine 2 theta plus a half. Okay. Now because, again, we are in quadrant 2, sine is positive in quadrant 2, so we're going to pick the positive radical instead of the negative radical. So we'll have sine of theta is equal to the square root of -1/2 times cosine 2 theta. Which is 4 over 5 plus 1/2. And I'll just write a little note here. Pick the positive square root because sine is positive in quadrant 2. Okay, so then if we go ahead and simplify that, we'll have the square root of -4 over 10 plus a 1/2. So multiply top and bottom by 5 again, and we'll have a -4 plus 5, so that's just a 1 over 10. We can write this as a square root of 1 over square root of 10, which will give us a 1 over radical 10. And if we rationalize, we'll have square root of 10 over square root of 10 times 1 over radical 10, so that'll give us a radical 10 over 10. From sine, we can find out what is cosecant. And we can do so simply by taking the reciprocal of the non-rationalized answer. It would be 1 over radical 10. So take the reciprocal and we get square root of 10 over 1, which is just radical 10. Okay, we have 2 more trig functions that we need to find, tangent and cotangent. Now if you look at the double angle formulas, there's nothing that relates cosine of 2 theta to tangent directly. So we're going to have to resort to a different formula or identity. If you take a look at the top left-hand corner, we do have that tangent theta is sine over cosine. So the formula that I'm going to be using is tangent theta equals sine theta over cosine theta. And that is because we do know now what is sine of theta and what is cosine of theta. So if we replace those values, sine of theta is a square root of 10 over 10 divided by cosine was a negative 3 radical 10 over 10. So dividing by a fraction is the same as multiplying by the reciprocal. That means that we'll have a square root of 10 over 10 times a 10 over negative 3 radical 10. The tens will cancel, the square root of 10 will cancel, and we'll end up with a negative 1/3. And finally, cotangent of theta. For cotangent of theta, we just take the reciprocal of tan, so that'll be a negative 3 over 1, which is just negative 3.